The back there beneath your feet, a hidden ecosystem that never sleeps. At first glance, a bag there seems still, a bed of grass, a light of stones, perhaps a tree, a fence, a forgotten corner where leaves gather and sunlight rarely reaches. To human eyes, it is a quiet space, often reduced to function, a place for laundry lines, flower pots, children's footsteps, or the simple habit of stepping outside for air, but beneath that familiar surface, an unseen world is already in motion. The back there is not empty space, it is an ecosystem in miniature, a layered landscape where soil, roots, insects, fungi, moisture, and light interact in rhythms far older than the house beside it. The moment dawn touches the grass, the ecosystem begins its visible shift. Dirt forms along the place, tiny droplets gathering from the cooling night air. To earth, dirt is aesthetic. Aside morning calm, to the ecosystem, it is water distribution. Small insects emerge to drink from its surface. Ants adjust their roots to avoid flooding. Beetles hidden beneath leaves sense the temperature rise through the thin membranes of their bodies. Spiders whose webs were built in darkness now reveal the geometry of the night's labor. Each strand holding bits of moisture that turn a hunting trap into a sparkling map of predation. At ground level, scale changes everything. A fallen leaf becomes architecture as curved edges create tunnels of shade where springtails feed on fungal threads. Mice move invisibly through particles of decaying plant tissue. Tiny nematodes swim within the thin films of water trapped between grains of soil. None of this can be seen from standing height. It is here that the back's true metabolism begins. Decomposition, nutrient cycling, and microbial exchange transform yesterday's dead matter into tomorrow's root growth. The soil itself is alive, not metaphorically, but biologically dense beyond easy comprehension. A handful of Baghdad soil may contain billions of microorganisms, bacteria, archaea, fungi, protozoa, microscopic worms, and dormant spores waiting for moisture. The organisms are not randomly distributed. They cluster around roots, beneath shaded stones, inside damp buckets of organic matter, and along the paths where rainwater repeatedly flows. The soil beneath a bag that is not static dirt, as a dynamic matrix of chemical composition. Roots are the silent engineers of the system. Grass roots, tree roots, weed roots, and the roots of forgotten garden plants extend far wider than their visible leaves suggest. Around the roots exists the rhizosphere, one of the most active biological zones on Earth. Here plants release sugars and signaling molecules into the soil, feeding bacteria and fungi in exchange for nutrients. Fungal hyphae stretch outward like underground highways, connecting one plant to another, redistributing minerals, moisture, and even chemical warnings. What appears above ground as isolated plants is often, below the surface, a connected network. As sunlight strengthens, the background begins to divide into microclimates. The open lawn warms quickly. Soil near the wall remains cool. The underside of stones stays damp long after exposed surfaces dry. The differences create ecological niche only centimeters apart. A bug may spend the morning beneath a brick, emerging only when humidity rises. An ant colony beneath the partial edge uses the thermal gradient of stone and soil to regulate broad development. A bed of moss in constant shade hosts moisture-loving invertebrates that would desiccate with 10 minutes in the nearby sunny grass. Human structures unintentionally expand the ecosystem. A wooden fence becomes vertical habitat for spiders, moths, bug beetles, and climbing ants. Cracks in concrete collect wind-blown seeds, allowing weeds to establish miniature islands abroad. The underside of a forgotten pocket traps humidity, creating refuge for earthworms and slugs. Even a hose left coiled near a wall alters moisture distribution enough to shape insect movement patterns. The backyard ecosystem is built not only by nature, but by the accidental geography of human life. Predation begins early. A spider web stretched between low branches captures nests drawn by moisture. A robin lands titling as hard to detect vibrations beneath the soil, hunting earthworms near the damp edge of a flower bed. A lizard on the wall wetted the ground below, waiting for movement. Every square meter of the bag that contains multiple food chains operating simultaneously, layered across high temperature and time of day. The leaf litter zone is especially rich. To many people, fallen leaves are mess. To the ecosystem, they are shelter, isolation, and food. Beneath a thin layer of leaves, moisture remains stable. Fungi colonize the underside, softening cellulose. Millipedes shred the material into smaller fragments, increasing surface area for microbial digestion. Ants carry pieces deeper underground. Worms prune decomposed matter into burrows, mixing nutrients downward. Over weeks, the visible leaf disappears, but as autumn remains, redistributed into roots, insects, and the microbial community. Backyard ecosystems are defined by repetition. The same corner receives treat water from a tap leak. The same branch casts afternoon shade. The same batch of grass is compressed by repeated footsteps. Organisms learn and adapt to the stable disturbances. Ant trails form around habitual human movement. Birds time their visits to moments of quiet. Insects exploit outdoor lights at dusk. The ecosystem do not resist human presence. It incorporates it. Rain transforms everything. Even a short shower can rethrow the ecosystem's boundaries. Dry soil becomes permeable, dormant spores awaken, worms rise closer to the surface. Temporary pools form in shallow depressions, allowing mosquito larvae or water beetles to exploit fleeting habitats. Fungus fruiting bodies may appear overnight after prolonged moisture, pushing through mold and shapes that seem sudden but were long prepared underground. That the bacteria's greatest mystery is not the visible life above the soil, but the constant exchange between what is seen and unseen. Every insect trail above ground mirrors chemical pathways below it. Every bird that lands on the fence depends on the worm population shaped by soil moisture and microbe density. Every flower that blooms is fed by 1,000 invisible acts of decomposition, symbiosis, and minor transport. The ecosystem never truly sleeps. At night, a different shift begins. Slugs emerge along the damp wall. Moths pollinate night-blooming flowers. Beetles patrol beneath leaves. Spiders rebuild damaged webs. Soil organisms continue their silent labor regardless of darkness. The bag that changes workers, not purpose, as metabolism is continuous. To stand in a bag that to stand above an active earth exchanges. Beneath every footstep, roots negotiate with fungi. Beneath every stone, moisture shelters life. Beneath every fallen leaf, that is being transformed into growth. What seems like still growth in is in fact a layered engine of survival. And it's only the surface of the story. In part 2, we move deeper into the day to night cycles of the backyard ecosystem, following how sunlight, temperature, and human routines reshape life hour by hour. By mid-morning, the backyard no longer resembles the place it were at dawn. The dew that once fed tiny insects begins to evaporate, lifting moisture back into the air. Sunlight sharpens edges, warms surfaces, and redraws the invisible boundaries between safe and dangerous space. What seems to Earth like the same there is, to the organisms living within it, a completely different world. Temperature alone changes who can move, who must hide, and who gains the advantage in the daily struggle for food. The urban grass becomes one of the first zones to transform. As the sun rises higher, the upper place heads quickly, creating a light, dry layer hostile to moisture-dependent creatures. Tiny springtails that fed freely at dawn retreat downward into shaded soil pockets. Petals sleep beneath leaves. Ants, however, become more active. Their bodies are built for rapid surface travel, and the warming ground increases their speed. Tails that were tentative in the cool morning now become highly organized highways, extending from cracks near the wall to fallen fruit, or insect carcasses. An ant trail is not simply movement, it is infrastructure. It individual deposits pheromone signals that strengthen what debated you, turning random exploration into collective memory. In the back door, deep trails often reveal the geography of the hidden ecosystem better than the eye can. They follow the fast like reshape remains longer. They curve around border-prone depressions. They pass beneath stones that offer emergency shelter from birds. In that way, ants map the bag down according to risk, temperature, and reward. Near the roots of shrubs and small trees, another layer of activity intensifies. Aphids cluster beneath leaves, feeding on plant sap through delicate nettle-like mouthparts. Their presence attracts ants, which farm them by harvesting the sugary honeydew they produce. In exchange, the ants protect them from predators like ladybugs and lacewing larvae. That relationship turns a simple plant stem into a microeconomy of exchange, defense, and dependence. The back that is full of the hidden alliances, invisible unless observed closely, and over time, as they grow warmer, birds begin to use the ecosystem differently. In early morning, many species forage directly on the ground, but late morning they shift toward shaded branches, fences, and roof edges, where they can conserve energy. From the vantage points, they continue hunting, but selectively. A sparrow may drop suddenly into the grass to seize an exposed insect. A blackbird may patrol the damp soil near a house where worms remain close to the surface. The birds are not random visitors, they are timed participants in the big, thus daily energy cycle. The insects themselves follow the clock of light. Butterflies and bees emerge more confidently. When flowers open fully in direction, pollination becomes the dominant interaction of the late morning ecosystem. A flowering herb near the word ignored at dawn may now host bees, hoverflies, and tiny wasps. Each species uses the same plant differently. Bees collect nectar and pollen. Hoverflies feed briefly while scouting egg-laying sites near aphid colonies. Parasitic wasps inspect leaf undersides for caterpillars or ants. A single flower cluster becomes the grounded intersection of ecological intentions. The soil beneath the flowers is changing too. At the civic worms, evaporation pulls water upward through capillary action, altering microactivity in the upper layers. Certain bacteria become more active as oxygen levels rise and drying soil. Fungal threads retract from the most exposed zones and continue expanding in cooler pockets. Earthworms, sensitive to heat and dryness, descend deeper into the ground. Where the temperature remains stable, their temporary absence from the surface affects bird which must now shift hunting strategies elsewhere. Human routines begin to overlap more strongly with the ecosystem by midday. A back door opens repeatedly, someone waters potted plants, a chair is moved into the shade, laundry drifts onto one patch abroad. These more ordinary actions create resource pulses. Watering a plant may flood nearby ant roots, forcing instant rerouting. Wet soil attracts gnats and fungus feeding larvae within 10 minutes. A dropped crumb near step can become the center of insect activity for hours. The Baghdad ecosystem is shaped as much by predictable human repetition as by sunlight and weather. The hottest part of the afternoon produces a visible slowdown, but only on the surface. Grasshoppers may remain motionless on stems, conserving energy. Bees retreat to nests or shelters foliage. Pests reduce unnecessary flight that beneath the moat, inside the soil, and under stones. Life remains highly active. Termites continue digesting dead wood fibers and hidden fence posts. Slugs rest in cool chambers beneath bricks. Centipedes patrol the darkness beneath plant pots, hunting soft-bodied prey. The bag that has entered as below-ground shift, where heat forces life into protected layers. Shade becomes one of the most valuable ecological currencies. In the afternoon, the narrow strip beside wall, shaded by the angle of the sun, can support an entirely different set of organisms than the nearby lawn. Moss remains damp here. Tiny snails graze microscopic algae from concrete. Fungus gnats hover in still air. A gecko on the wall waits for insects drawn to the coolness. The microhabitats exist only because of the dense architecture where nature and human-made services intersect. By late afternoon, the balance begins to change again. The heat softens, shadows lengthen, activity returns to the surface. Ants intensify foraging before nightfall. Beetles emerge from beneath leaves. Birds resume feeding on the lawn. Spiders damaged by wind or bugs began repairing their webs in preparation for night insects. The ecosystem is not simply becoming active again, it is changing workforce, with species adapted to twilight taking over from those optimized for full daylight. Then comes dusk, the most dramatic transition in the Big Dar. Light fades unevenly. The grass darkens first, while upper branches still catch the last glow. That creates temporary vertical layers of activity. Moths began fluttering near flowers that release stronger evening scents. Mosquitoes rise from damp corners and steal water hidden in gutters, pockets of plant trees. Bats, if the area allows, may sweep overhead, converting the insect bloom into rabbit aerial feeding. Frogs near water just begin calling, their sound turning moisture and darkness into acoustic territory. Artificial light introduced a second ecosystem clock. Port lamps, kitchen windows, and nearby street glow reshape night behavior. Insects that navigate by moonlight become disoriented by bulbs. Moths spiral around warm light sources. Tiny beetles gather near windows. The sudden concentration attracts predators. Spiders build webs near lamps. Geckos patrol wards just outside the claw. Night birds and bats learn the feeding hotspots. A single light pop can become one of the most energy-dense locations in the entire Baghdad food web. The leaf Little John, quiet by day, becomes highly active at night. Slugs glide over decomposing plant matter, feeding on fungi and soft leaves. Mealy bats resume shredding organic debris. Good, dry, good lice emerge from beneath stones to graze on moisture soften cellulose. If observed with a flashlight, the dead corner of the jar suddenly reveals itself as one of the busiest spaces in the ecosystem. Even the air changes function at night. Cooler temperatures allow scent molecules to travel differently. Having nocturnal pollinators collocate flowers. Sound becomes more important as visual cues weaken. Crickets establish acoustic territories. Tree frogs answer from damp vegetation. The ecosystem shifts from light-driven to sound and sun-driven behavior. That beneath only visible transitions, the soil continues as a constant work. Bacteria multiplies fresh organic inputs from fallen petals, insect remains and root exudates. Fungi transport nutrients between shaded root systems. Worms slowly process decomposed matter into richer soil structure. The bag that never pauses. It only redistributes labor across species and time. What makes the day-night cycle extraordinary is how perfectly it is tied to small environmental differences. A single stone that stores daytime heat may stay warm enough at night to attract insects. A wet bed from afternoon watering may remain active until dawn. A plant casting shade in the morning becomes a bird for hours or night insects by evening. The ecosystem is built from repeated daily transitions, and every species has evolved to occupy specific moment within them. To Earth, the bag that seems to become wet at night. In truth, it becomes more layered, more strategic, and in many ways more alive. In part 3, we will go beneath the surface itself, exploring the underground networks of roots, fungi, tuners, and soil organisms that power everything above ground. If the bag does survey the visible state, then the soil beneath it is true engine room. Every blade brush, every flower, every insect drill, every bird that lands for a worm, all of it depends on a hidden system operating just below sight. The underground world is not empty dirt. It's an intricate city of tuners, roots, fungal highways, microscopic predators, moisture channels, and chemical conversation that never stop. To kneel down and touch the soil is to touch a living architecture. The uppermost layer, often only a few centimeters thick, is where dead leaves, grass clippings, fallen petals, insect remains, and pieces of bark begin their slow transformation. Here, bacteria and fungi begin breaking complex organic matter into simpler compounds. What appears to Earth as decay is, in ecological terms, a redistribution of energy. Carbon locked in that stays left becomes food for microbes, then nutrients for roots, then tissue for tomorrow's flower. The back thus underground ecosystem begins with the later layer, where the remains of surface life collect. Tiny springtails lay between fungal threads, mice feed on microscopic spores, millipedes chew softened fragments of leaves into smaller particles, making them easier for bacteria to digest. Slender worms move through the jam debris, carrying particles deeper into the soil. Every organism in the layer reduces complexity, transforming large structures into forms usable by smaller and smaller life. Beneath the litter lies the root zone, one of the most biologically active regions in the entire ecosystem. The roots of grass, weeds, shrubs, flowers, and nearby trees overlap into a dense mesh. To Earth, plants appear separate, each occupying its own space. Underground, the boundaries blur. Fine roots extend far beyond visible stems, weaving from through each other and into tiny pores in the soil. Around every root tip is a hollow of intense activity known as the hydrosphere. The hydrosphere is where plants and microbes exchange resources. Roots release sugars, amino acids, and signaling compounds into the soil, feeding bacteria and fungi. In return, microbes unlock phosphorus, nitrogen, and trace minerals that roots cannot easily access alone. Some bacteria form nodules on roots, fixing nitrogen directly from the air trapped in soil spaces. Fungi extend thread-like hyphae far beyond the reach of roots, pulling in water and nutrients from distant pockets. In effect, the plant is outsourcing part of its survival to a vast microbe workforce. One of the most extraordinary structures in the underground city is the mycorrhizal fungi network. The fungi threads connect plant roots across surprising distances, linking grass to shrubs, weeds to trees, and even young seedlings to other established plants. Through the networks, water can be redistributed from moist zones to dry ones. Nutrients can flow toward shaded plants that need support. Chemical warnings about insect attack can spread from one root system to another. The background above may seem like a separate patch of green, but below it often behaves as a connected community. Moisture determines much of the underground ecosystem's design. Rainwater does not simply soak in, it follows channels created by roots, wound, burrows, old cracks, and differences in soil texture. Sandy zones drain quickly, favoring organisms adapted to fluctuating moisture. Clay-rich pockets hold water longer, creating stable environments for bacteria. nematodes and fungomas. The egg beneath a dripping hose may remain wetter than the rest of the jar for days, becoming a permanent hotspot of microbe growth. Earthworms are among the most important engineers in the hidden world. Their burrows create vertical shafts that allow oxygen, water, and roots to penetrate deeper layers. As worms consume decomposed material, they produce cuttings rich in nutrients and beneficial microbes. The castings improve soil structure, helping it hold both air and water. A backdoor with healthy worm seed activity often supports stronger plants, more insects, and more pests above ground. In that way, aerobic hunting on the lawn is directly linked to the engineering work of worms far below. The soil is also full of predators too small to notice. Nematodes hunt bacteria, protozoa consume other microbes. Predatory mice stalk springtails through damp organic pockets. Even at the microscopic scale, the ecosystem is structured by food chains, competition, and resource distribution. The underground city is not peaceful, it is dynamic, competitive, and constantly self-regulating. Human-made structures above ground shade this subterranean world more than we realize. The shadow of a fence keeps one side strip cooler. A concrete walkway redirects rainwater, concentrating moisture at its edge. Repeated footsteps compact one area, squeezing air from the soil and forcing roots to reroute. A garden bed enriched with compost becomes a zone of explosive microbial diversity. Even the forgotten spot where flowers pot sat for months lives behind altered soil chemistry and a compressed moisture pattern long after it is moved. Terrors at an entirely different scale to the underground city. A major backdoor tree may extend roots far beyond beneath patios, fences, and neighboring plots. These roots stabilize soil, create shade-linked moisture zones, and feed vast fungal communities. In autumn, when leaves fall, much of their decomposed nutrients return to the same root system, completing a cycle of vertical exchange between canopy and soil. What makes their underground ecosystem extraordinary is its memory. Soil retains the history of seasons, storms, human happiness, and plant succession. Areas repeatedly watered host different microbial communities than dry corners. Our compost zones remain nutrient-rich for years. Former ant nests alter soil aeration long after the colony moves. The bag that is not just alive beneath the surface, it remembers. Night intensifies the underground life in ways we rarely imagine. Cooler temperatures bring worms closer to the surface. Moisture resists through capillary action, reactivating bacteria near the upper layers. Beetle larvae feed more actively around root zones. Fungal growth accelerates in damp, dark conditions. while the surface ecosystem changes shapes from birds to moths. The underground city also changes workers, becoming more fluid and moisture driven. Perhaps the most remarkable trait is that the visible beauty of a back, the green grass, blooming flowers, visiting birds, is only the expression of the hidden city sunset. Above ground life is the result, not the cause. The underground world supplies water, nutrients, structural stability, and resilience against drought, disease, and disturbance. A single healthy square meter of big the soil can contain kilometers of fungal threads, thousands of insect larvae, millions of bacteria, dozens of worm tuners, root tips from multiple plant species, dormant seeds waiting for the right conditions, spores of future mushrooms, chemical traces from yesterday's rain. This is why a bag that can recover after stress. A dry week ends and grass greens again. A flower cut bag returns stronger. Fall leaves vanish into richer soil. Recovery is possible because the underground city never truly shuts down, and that is fragile. Except chemicals, overcompaction, steroid landscaping, and constant disturbance can collapse the networks. Without fungal threats, plants weaken, without worms, soil hardens, without microbial diversity, nutrient cycling slows. The surface may still appear neat, but the ecosystem beneath loses its resilience. To understand the back fully, we must stop thinking of it as a surface and begin seeing it at depth. A vertical ecosystem where the most important processes happen in darkness.